Hello and welcome to STEM Pursuits with Mr. Clausen, and today we're going to explore how to factor simple quadratic expressions in Algebra 2. Specifically, what we're going to be looking at today is we're going to be determining how to find greatest common factors. We're going to be looking at how to factor expressions of simple quadratic equations, specifically when the a coefficient is equal to 1 of a y equals ax squared plus bx plus c equation. So we'll look at some examples of those. And then I have a combined application problem for you at the end of this video. So to start off, in terms of factoring quadratic expressions, one of the things that I want you to be able to do is I want you to look at a quadratic expression like this. And specifically, this is a simple expression overall, but one of the things that I want you to be able to do is be able to pull out common factors. So in this specific quadratic expression, we have a common variable of 3 in both of these equations. So if we look at 3a squared, we can easily split this up into 3 and a squared, and we can easily split a 9 into two 3's. So all I'm doing is using division to separate these values into their prime components. And one of the things that you can do is that if you have an expression like this and you have a common factor between two of them, they can be removed and put out front of a very specific expression. So in this case, we could pull out the 3 and then in parentheses go a squared plus 3. To show you a similar example again, we're going to look at a situation where we have 14y squared plus 7y. Again, I'm going to do the same thing. I'm going to pull out a couple different variables here. So I'm going to pull out a 2, a 7, and there's two y's here as well. And actually, let's write all of these out so that we can see them all. And then I'm going to do the same thing with the 7 and the y here. We can separate these out into their specific prime components. And then what I want to be able to do is I want to find if there's any common factors. So what I see is a 7 and a y here. And I see that there is a 7 and a y here. So what that tells me is that 7y, the GFC, the greatest, or GCF, is the greatest common factor. And the greatest common factor for these two variables is just simply 7y. So we can pull that 7y out of both equations, and in parentheses what we do is we stick what's left. So there will be a 2y here, and then we pulled everything out for the 7y, but because we still need to acknowledge that that was in existence, technically there would still be a 1 there. You multiply anything by 1, you get it itself. So technically we still need to leave that there, but we can go 2y plus 1. And then this expression would be factored. Now when we factor something, we're never changing the value of the expression. So if you ever want to check and make sure that you did this right, it's very easy to do. You just take the expression that you just factored, you distribute the 7y back into it, and as long as you get the 14y squared plus 7y back, which is your original equation, and it works out, then you know you factored it out correctly. The second skill that I want to look at specifically with you today is looking at how to factor simple quadratic expressions. So this is very specifically a situation where I was talking about with a quadratic equation, if you have y equals ax squared plus bx plus c, I'm specifically talking about situations where a is equal to 1. This is very specific situation that we're talking about here. If a is not equal to 1, we're going to talk about that in a different video and how to approach those problems, but all the examples I'm talking about here is a being equal to 1, with this b is equal to 10, and c is equal to 16. Now, what I want to do with a quadratic expression like this is we want to figure out how to factor it. So, and specifically, I want to be able to figure out how to factor it into two binomials. So my end goal is to go and make something that looks more like y equals x plus some variable. We'll just choose w, and then x plus some other variable z. Again, I'm just making these up for the sake of format. This is really what I'm targeting and trying to shoot for, is get this. And there are some techniques that we can use in order to do this, because really what we're trying to do is unfoil this quadratic expression. So how to do that is there's a little trick that I always like to pull towards. And the trick is that the sum of your factors that you have, the w and the z here, should equal 10, should equal this number right here. And the product of those values should always equal 16. And there's things called the AC box method that some people use. But what I simply like to do in a situation like this is the A and the C value, if I take my A and my C value, A times C, and in this case it'd be 1 times 16, this is simply equal to 16. And that's why we're very specifically talking about situations where A is equal to 1. And what I like to do in these particular situations is if I see that my constant here is equal to 16, and we're trying to factor a simple quadratic expression like this, is I want to find all the factors of 16. So to factor out an expression like this, normally what I'm doing is I'm going through and I'm saying, okay, what are all the possible factors of making positive 16 when I multiply all these together? Because this is my C value right here. And all the possible factors of making positive 16, well, 1 and 16 would be a possibility. 2 and 8 would be a possibility. 3 is not a possibility, but we could go 4 and 4. And if you're not sure, sometimes what I do is I just take my calculator and I start dividing a number by all of its primes. So divide by 1, divide by 2. If I divide by 3, you know, it'll give me 5 and 1/3 or something like that. And I know that's not really a situation that I'm looking for. Let's see, we can go 8 and 2, but then we just start repeating all the things that we have again, and we start over. But you know, we could multiply by -8, -2, -4, -4. Let's see, -1, -16. And this would encompass all of the possibilities, at least using whole integers that are products or possibilities for factors of 16. Now the reason that I'm doing this is I'm looking at all these possible factors because, again, like I said, I'm unfoiling this. So one of the things I want to be able to do is I want to find a factor of 16 that is equal to the B value of my quadratic expression. So what I'm going to do here is I'm going to look at all of these factors and I'm going to go, well, what's 1 plus 16? 1 plus 16 is equal to 17. 2 plus 8 is equal to 10. 4 plus 4 is equal to 8. And -2 plus -8 is equal to -10. So you would just have the reciprocal values here, or the opposites, I should say. Now, all I want to do with this is I know my B value is equal to 10. And all I'm trying to do is I'm trying to find the B value that matches this possibility, which is right here. So that tells me that my factors that I'm going to use to simplify this quadratic function into two binomials are simply going to be 2 and 8. And you might be thinking, why does this work? Well, it works because we're trying to do the opposite process of foiling. So first, outsides, insides last. And what we're doing here is we're finding the insides. And here we're finding the lasts. And what you can do with this is, for example, if you know that these are your factors, what I'm saying is that this is your W and your Z over here. So what you do to conclude is you just say X plus that factor and X plus this factor is equal to the original expression that we're trying to we were given. And if you're not sure if you did it right, all I would do is FOIL it. So x times x gives you x squared. 2 times x gives you plus 2x. 2 times 8 gives you positive 16. And then x times 8 gives you plus 8x. And if you notice here, you combine the 8 and the 2. That's what we had over here. That gives you the 10x. That was a part of your original quadratic equation. The 16 is the constant, which is the products that we were looking at over here. And these two binomials give you the final answer that you're looking for. So when you're factoring a simple quadratic expression, you take those factors, and this would conclude the answer that I'm looking for in a situation like this. Another example, just to walk through the process again. Again, I'm looking at all the factors of 24. If I identify this as a 1 here, all right, it's a simple quadratic expression. So the first thing I'm going to do is I'm going to split this apart. I'm going to look at all the possible factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then when I get to 6, it's going to go back to 4. So then that's just going to repeat itself. So let's look at the negatives as well. So negative 1 and negative 24. Negative 2, negative 12. Negative 3, negative 8. And let's see. And we'll go negative 4, negative 6. So this is my C value, and these are all the different products of my C value. And I want all the products of my C value. I'm hoping by some chance that one of these will have the sum of the B value right here. And if I can get the B value to equal the sum of any of these combinations of factors, then I can simplify the expression using those coefficients. So I'm just going to go 25, 14, 11. And what I will say is that you generally will not have to go through this process every single time. I can tell that the answer to this specific expression is all the way at the bottom. But what you will need to do is, if you're not sure where to start, is just start breaking this apart, looking at these factors, and eventually, if there is a possibility, it will come out. So what I'm seeing here is that negative 4 and negative 6 are factors that I can use to separate this quadratic equation into two-factored binomials. So that now that I know that negative 4 and negative 6 are my factors, I can simply say x minus 4 in parentheses times x minus 6 in parentheses is my solution that I'm aiming for. And if I go and distribute this, I go first, I get x squared. So if I go x times x, that's x squared. And then I do so my outsides, x times negative 6, that would give me negative 6x. Insides, negative 4 times x would be negative 4x. And last, which would be negative 4 times negative 6, that'll give me positive 24. I simplify accordingly, and I will see that I get the original quadratic back, and that we're all good to go. So to conclude this lesson, I want to go through one more problem where you can combine both of these ideas. Now, we can take an expression like this, and the reason I point this out is that we have an equation here that has a 2 in the front. And what we're going to talk about in the next lesson is how to deal with these specifically. But one of the things I want you to always be keeping an eye out for is that, hey, if there's a greatest common factor that we can pull out of a trinomial like this, you should really take advantage of that. Or if there is a variable that's shared between all three components, you should really take advantage of that. Because what I'm going to show you here is that, hey, if we pull out 2 and x squared, and we pull out 2 and 2x, and we pull out 2 and negative 63, what we can do is we can make this trinomial from a difficult problem to a really simple one by simply pulling out 2. Because instead of having the 1 there, we can pull out the 2, we turn it into a simple polynomial, and then we get this guy to work with. And we still have the 2 there. We can't just ditch it and throw it away. It's an expression, so we can't divide 2 out of it and get rid of it. But hey, now we went from a kind of gross trinomial problem to a really much more digestible version of it. So again, what we want to do is we want to look at all the possible factors of 63. And what I'm going to do here is sometimes I don't know what all the possible factors are, so I'll grab a calculator and I'll go 63, and I'm like, is that divisible by 3? Well, it is. So I can go negative 3 times 21, or 21 times negative 3. It's not divisible by 4, not 5, but 63, is it divisible by 7? Oh, it is. Okay. I'm going to go 7 and negative 9 and negative 7 and 9. And I just moved on from 3 and 21 because I could see that the sum of these numbers would not equal 2. But I see here that if I add these two, this is positive 18. This would just be, oh, I did the same thing twice here. This would be negative 18. Those don't work. But hey, 7 minus 9, that's negative 2. And negative 7 plus 9 is positive 2. This is what I'm looking for because I see it here. So if I use 7 and 9 as my factors, what I can do, I need to carry the 2 over as well, but I can write this out as 2 times x minus 7 times x plus 9. And this now will be a factored quadratic expression that is now in correct form. So as you can see, we simply factored out the 2 to start. We found the factors of 7 and 9. And we were able to take this larger, more complicated quadratic expression and simplify it into much smaller, more digestible parts. I hope this video was helpful, and I look forward to seeing you all in class tomorrow. Have a great day.